All right, welcome back, everybody. We got a nice 5-day week this week. Sorry about that. Last week was nice. I mean, a 3-dayer for us, but it is what it is. Good day for me. My team won. Boy, did I get lucky. Woo! Steelers. Oh, so I guess they come to town. And so you're a Broncos fan, good for you. I always hate when my best team, my favorite team in the whole world, plays my second favorite team in the whole world, because then, I have to root for my best favorite team. And my household kind of, I lose by a 3-4 vote because my daughters, my wife support the Broncos solely. So I might be sleeping here at school, but that it is what it is. Hey, how you doing there, Cupcake?
I'm doing well.
Hey, for a little. He is here now. So, sad news in the entertainment industry. David Bowie passed away, cancer. Sad. It's an entertainer that I enjoyed. So, everybody loves you. So, this week we're going to continue with our systems of elimination. Tomorrow will be kind of a mix. We'll go over the graphing, substitution, elimination. Wednesday we'll do review practice. Thursday we will indeed have a quiz, and then we'll start out with inequalities. And I'm going to kind of switch up how I go with questions. I've put all of your names on this, and I've mixed them up. So when I go around the room, bounce around, and some of you are forgetting. That's not because I hate you. It's just because I forget who I've asked. This will keep me honest. So I mixed these up. So, Mackenzie, because your name was up front, or I put you at the back. You get the last question. All right, Christian, coming to you. So let's talk about this real quick before we go over the homework. Why would graphing not be the most ideal way to go through to solve a system of equations, two linear equations? Why would it not be a good way? What'd you think? No, don't pass. You don't pass. You don't. Okay, so it's crossing right here. Can you tell me exactly where that's crossing? Crossing right there. Okay, where is that? Give me the ordered pair. Because you don't know, right? But you don't know always. That ordered pair could happen way out here, way over there, way down there. It could happen some weird fraction, right? So Preston, welcome back. I'm going to pick on you for your next question. Do you recall what happens if I have two lines that are parallel to each other and they don't cross, what the answer would be? No solution, absolutely. Look at that. He's gone all last week and he nails it. Okay? Hey, Bo. We have two lines lying right on top of each other. Okay? How many solutions we're going to have? Infinite solutions. I like it. So then, as we go through, Sophia, coming to you. If I were to have used substitution or elimination, and all of my x's and all of my y's fell out, and I wind up with like 7 equals 7, which is true. Do you agree with that? What would our solutions be? Would it be an x comma y because the x and y's fell out? Would it be no solution, or would it be infinite solutions? Infinite's absolutely right. Good deal. Megan, coming to you. So Megan, if infinite solutions was like 7 equals 7, or 12 equals 12, what would the result be if there was no solution? It's like 7 equals 1, so it gives you an untrue thing. So you remember that? Is that okay? All right. So cool. So let's walk through a little bit of the assignment. See how we did. Any questions of what's going on this week on the board? Feel okay about it? Yeah. And Preston, we're still in the old booklet for right now. Oh. Did you get it? And then we'll get a new one. Did you throw it away?
Yeah.
Okay, here, I'll get you a new one.
$5.
So that should take care of you for a while. And as soon as my computer. So 3A was our homework, right? Solve each system. Solve each system using the elimination method. Okay. Computer is thinking now. Good. Come on. All right. While it's thinking about what it wants to do, TJ, you are next up on questions. When would substitution not be the better of the two methods between that and elimination to use? When would substitution not be a good time to use it? What has to happen? Remember substitution, it's going to be like y equals, and we plug that back in, right? So think about if I had like 16x plus 8y equals 7. Yeah, so when it's not easy to solve for x or y. Anyone, any ideas up here, guys and girls? I got a death wheel spinning. We might have to go old school here.
How old?
Go with the whiteboard, not to the chalkboard. All right, going here. All right, moving this over. Don't panic. I taught for years without a smartboard. This just doesn't write that well. All right. Any questions from 1, 2, or 3? Any questions? Anyone want to see 1, 2, or 3? Talk to me, bro. Number 1. Here we go. 2. 2. All right, we're starting with number 2. Holding the horses.
Doing 2.
All right. All right, let's see how we do with this. See how we do. Casey. So remember the elimination method, we are going to combine the two together, correct? If I were to add these together, does something fall out right away? Meaning the x's or the y's. The x's fall out. So this one has been set up nicely for us. Do you agree? What's my password? Anyone remember? Big boy, correct. All right, so Casey did and indeed say that if we added these together, the x's go away. Oh, sweet, we can go back to that. All right, so x's are gone. This cancels this nicely, yes? If I add 3y and negative y together, I get 2y. If I add 11 minus 9, I get 2. So what's y equal to then? It's 2 over 2, which is 1, right? Okay, so once I found my y component, what should I do in order to get my x component reached? Plug it in. Which one would you like to plug it in? Top or bottom?
I'm gonna have to say the top one.
Top one? Okay, I like it. So, again, once you go plug it in, you just have to make sure that the equation you're plugging into still has both x and y. So reset, let's do it with the top one. So I'm going to plug 1 in right here. So bringing this down, I'm going to get negative 4x plus 3. There was a y there. Now I'm putting what? 1. So So I get this plus 3 equals 11. Solve the system, so subtract 3. Negative 4x equals 8. Divide each side by negative 4. So I find that x is equal to negative 2. So my solution to this problem would be negative 2 comma 1. Cool? All right, coming back to the electronic board because we can. Lights go back out. Dimming the lights. All right, are we good on 1, 2, 3? They're all done very similar. 4, 5, 6. Anybody? 4, 5, or 6? Georgie.
Make it 6.
Making it 6. I like it. Number 6 was the chosen one. So I have 2x. I'm going to add it to 3y, which is equal to 2. I have 4x minus 9y equals negative 1. Okay, Gabe, coming to you. Ready? I just need you to answer this question. If I add those two together right now, is there a letter that is completely gone? No. Does everyone agree with that? So if I add those two equations together, I'd wind up with 6x minus 6y equals 1. And we want one of the letters to eliminate. Gage, is there one of the numbers up there that has a positive and a negative between the two? The 4x negative 9, okay? So I'm looking either at the x's or the y's. So do you think the x's have an opposite value or the y's as far as an opposite sign? The y's. Does everyone agree the y's have an opposite sign? I have positive 3y, I have negative 9y. A couple of you are screwing around a little too much, so pull them back together, please. Okay? So, being this and this are taking place on the y's. Mac, that means I'm going to eliminate the y's. So do you feel that I could multiply one of the equations or both of the equations by two different numbers or one number to get completely opposite sign values for my y's?
Yes.
Which one would you like? What would you like to do?
Top one.
Okay, we're going to multiply the top one. What are we multiply the top one by? I want to get opposite values on my y's. So
So would you do -3?
you're real close. Now, remember I said we have opposite signs. So right now I have positive and negative. I like that. I like that one's positive, one's negative. So I'm not going to multiply the whole top one by -3. I'm just going to multiply it by what? You do. 3, yeah. So if I multiply everything here by 3, here, and here, and here, that's going to give me 6x plus 9y equals 6. And let's just move this equation over. Ray, if I add these new red equations together, do the y's fall out? Everyone buy into that? The y's are gone now. Okay, so if I add these two equations together now, I'm going to get 10x. The y's are gone because they're opposite value. Yes? And then, what about this? What happens when I add those together? I get 5. So what's x going to be equal to? 5 over 10, right? Which is 1/2. Hey, does this justify that graphing might not have been the best solution to happen on here? Why is that?
It's a fraction.
I got a fraction.
Yeah.
All right, Andrew. I have found that I have an x value being 1/2. I want to find a y value. I would like to plug back into my blue equations, my original blue equations. Which one would you like? You pick, top or bottom. Top one? Okay, so my top equation was this. Agree?
Yeah.
I'm going to plug 1/2 in for the x. So I'm going to get 2 times, there was an x there. What am I going to put there now? I'm going to put 1/2 there. 2 times half is 1. 1 plus 3y equals 2. Help me out. What should I do, Andrew? Subtract 1, I like it. What that is. Subtract, cancel. 3y equals 1. Y equals 1/3. Again, this assures us that if we had graphed this problem, it would have been a little bit tougher to figure out where exactly it crossed because we're crossing at fractional amounts. That was a good problem. A little bit of luck. Thanks for asking for that one. I'll do 7 and 8 both, okay? Sound good? Deal? Deal? All right. Garvey's going to be coming to you. You're up next. Clear and 8. Number 7 we're doing first, then we'll do number 8. So I get 2x minus 3y equals 17. Then I get 4x minus 6y equals to 25. Garvey coming to you with a plethora of questions. Question number 1. If I add these two equations together right now, does the x or the y eliminate? No. If I add the equations together right now, I'm going to wind up with 6x minus 9y plus or equals 42. So that keeps still x and y. All right, Garvey, next question. Between my x's are the two equations, and between my y's are the two equations, do I have opposite signs? So if you look at the x's, what are both signs on the x's? Positive. What are both signs on the y's? Negative. I do not have opposite signs. Agree, everybody? If I don't have opposite signs, what should I do guaranteed right now to at least one of the equations? What would I have to know? I don't know what I'm going to multiply by. But being I don't have opposite signs, what should whatever I multiply by be? Negative. Good. Okay, so I know I have to multiply one of these by a negative. Ashley, coming to you. I know you just answered a question. Ashley, help me out.
So you multiply it, the first equation by -2. And then
I like it. Hang on. Multiply the first equation by -2. Are you choosing to get rid of the x or y's? What do you think?
the x's.
Okay, so Ashley's choosing to get rid of the x. That's your first assumption, and she figured that if you multiply the first equation by -2, the x value on the first equation would be -4x, and the second one would be +4x. So I'm going to distribute that -2 to everything on this first one, so I'm going to get -4x plus 6y. Hey, why did that become a +6y? Anybody?
-2.
A -2 times a? -3. And then I got a -34. Okay, second equation, we didn't have to change it. Ashley, something unique going to happen up here?
It's going to be no solution because x's and y's cancel out.
Yeah, that canceled and that canceled. We get 0 is equal to -9. And we didn't find some hidden secret in math. That 0 is equal to -9. So that's a strange situation. This is false. This means we have no solution. Ashley, if we have no solution and they were graphed, what can you tell me about the lines on the graph? Real close. Parallel, good. Parallel, if they're parallel, they do not cross. I like it. All right. Shh. So this one came up with a unique scenario because we tried to eliminate. We didn't do anything wrong because everything fell out. We wound up with a false scenario. That means the lines were parallel. If they're parallel, they would not have intersected each other. This means we have no solution. Okay? We'll also do number 8.
Yes.
Hey, Kieran, coming to you. Ready? Kieran, you ready? All right. As of right now, looking at the x's or looking at the y's, do the x's have opposite signs, meaning positive, negative? Yes? What about the y's? Okay? All right, so now we have to figure out, let's get rid of either the x's or the y's. Okay? So being we have opposite signs on x and opposite on the y, doesn't matter which one we pick, we're just going to have to multiply by some number in order to get it. So would you like to eliminate the x's or the y's? Your choice. Let's get rid of the y. So if I have a negative 3y here and a positive 9y here, what would I have to multiply the entire top equation that the y's would be opposite values of each other? Yes. And we didn't have to do a negative this time because we had a positive and negative, so we already have opposite signs. So if I distribute here, here, and here, that's going to give me 12x minus 9y equals 36. And then this one I'm just bringing right on over. Karen, do you notice anything that's going to happen with this problem when I add them together? Yeah. So that's gone. That's gone. What do I have on this side then? 0. Oh, wait. What happened there?
Oh my gosh.
Is 0 indeed equal to 0? Yeah. That's a special circumstance, yes? So remember on the last board, we had nonsense. We had one number equal to something totally different. Those were parallel. So what do you think this would have looked like if we would have graphed it? What? Yeah, the two lines on top of each other. So if I had graphed this, both lines would have fallen on top of each other. This is totally true. We agree that 0 is equal to 0. So this means we have infinite solutions. This means that they are the exact same lines. Yeah, you had a question, Tristan?
Would it be on the X or Y?
Oh, as far as those graphs went? I don't know. I just think it would be a line like this, or like this, or like this, or like this, somehow. And then the other one would be right on top of it. But I don't know exactly what it would look like right away. I mean, I guess if I could use the cover method, I'd wind up with x equals 3, y equals negative 4. So that would be kind of like this, That's what the line would look like. And then the next one would lie right on top of it. Yeah?
How is it infinite solutions?
Because this is true. That means that you're graphing the exact same line on top of itself. So for every point on one line, will it result in every point on the other line? If it did this, we would have solved an x equals a number and a y equals a number. Okay? Woo! Hey, problem number 9. We got a story. Steven, we got a story problem, man. We're going to learn something. You ready? Yeah! All right. It's problem number 9. We're changing up this story problem. Steven has 29 coins in his piggy bank. Steven's looking at it going, my name's not there. Steven has 29 coins in his piggy bank that are nickels and dimes. Yeah, there isn't any of the Chuck E. Cheese tokens in there. It's just nickels and dimes. The value of that piggy bank is $2.15. Let D equal the number of dimes. Well, why would we choose that? Well, D and dimes start with D. Okay? And N equal nickels. Why is that? Because N and nickels is the same thing. All right. So, are we okay with this piggy bank? Let's see if I can draw a piggy. There's the nose. Hey, what's that? What's that? That's the rubber cork in it, right? And then, hey, what is that? Yeah, insert the coins. All right. So, inside this piggy's belly, there happens to be nickels, and there happens to be dimes. Steven, you still with me in this adventure? We still here?
Yeah.
Steven, how much total money we have in our piggy bank that happen to be nickels and dimes? $2.15. So of those nickels and dimes, there happens to be $2.15 that total in this piggy bank. Okay? Steven, how many total coins do I happen to have in this piggy bank that happen to be nickels and dimes? I have 29. So I have 29 coins for a total of $2.15. And we know that they're all nickels and dimes. Okay, how do we know this? Maybe we pulled the plug out of the gut, emptied it out, going, oh my gosh, they're all nickels and dimes. And perhaps you separate, okay, here's nickels, here's dimes. I don't know. But we know this story consists of this. Okay, so if I were to take my nickels and my dimes, I look at them and I go 1, 2, 3, 4, 5, 6, and I get all the way up to 29. I know that my nickels and dimes would be a total of 29 coins. Steven's still with me on this adventurous story. I'm excited. I want to see what the conclusion's going to be. Okay. I know. This is exciting. All right. Steven, curveball coming your way. You ready for it? I think you can handle it. How would you tell, a nickel is worth 5 cents, do you agree? But how would you say that a nickel in relation to $1? It's not half a dollar, because a half dollar is 50 cents, right? So if a nickel, so if 5 cents is a nickel, notice this sign here, that's a dollar sign. How do you think you would make this work with a dollar sign? Ooh, little curveball coming.
Dude, you can't say things. Can you repeat that?
I can, I totally can. Because this is a big, I'll tell you what, guys and girls, this is a huge problem in society. It's not just Steve's problem. I'm just picking on him because I love him. And he was the next in the problems. All right, so how would I, if 5 cents, how would I write that with a dollar sign? I'll tell you that there is a decimal that's in front. How much? 0.3 cents? 0.36? Wait, I'll tell you this. 0.36 is 36 cents. Okay? How would I write 5 cents as a decimal with the dollar sign? Yes, you do. How much is a nickel? How much is a nickel? What did you say? 0.05. 0.05 is 5 cents. Okay? All right. I bet you. Hang on, Steve. You're getting there. He's like, dude, you're still picking on me, pal. I know I am. Okay. 10 cents is a dime. Yes. Okay. You're totally gonna get this one. So 10 cents. If 5 cents is 0.05, 10 cents is double that. Yes. So how would I write 10 cents with a dollar sign? Huh? I think 0.10. Okay. All right. So I put you on a tough spot. I really did. Good job. I applaud you for it. That was tough. You're off the hook for the rest of the day.
Whoa.
Well, just keep staying along with it. All right, Celine. We okay that 5 cents is 0.05 of a dollar and that 10 cents is 0.10 of a dollar. Does that make sense? Okay, so I know that my nickels and my dimes is just all my coins sitting there. They all have to be nickels and dimes. They're all poured out and going, oh, look at the nickels and dimes. How many are there? 1, 2, 3, 4, 5. There's 29 of them. So I've counted up my nickels and dimes. But being that all my nickels and all my dimes is $2.15, Celine, I'm going to do the first one for you. I get 0.05N plus 0.10D. I like it. 0.10D. And that has to equal how much? $2.15. Okay, now, we got decimals up there. Okay, so we have a choice. We can continue to do this whole problem in dollars, or I can convert it to cents. If I convert it to cents, that means I'm going to take that whole bottom equation. Still with me in this adventure? Take that whole bottom equation and multiply by 100. And if I multiply by 100, that means the decimal will move 2 places to the right. So if I take this whole problem and multiply by 100, I'm not trying to eliminate anything. I'm just trying to get rid of the decimal because it's kind of nasty right now. Okay, so if I multiply here and here and here, I will move the decimal 2 places here. So that's 5N. I will move the decimal 2 places here, which is 10D. And if I move the decimal twice here, 215. Okay? So now, this is representing cents now. Okay? So I'm going to use this equation now and this equation now to solve my nickels and dimes. Still with me? Celine, coming back to you because I didn't really give you that hard question. I know you can handle it. If I were to add the n plus d equals 29 and the 5n plus 10d equals 215, if I were to add those equations together right now, does an n or a d cancel out? Okay? Next question. You're absolutely right. Next question. Do I have between my n and 5n, and d and 10d, do I have opposite sign? No. Does that make sense?
Yes.
Okay, so if I don't have opposite signs between my n's and my d's, so n to n, d to d, I need to go and multiply by a negative whatever equation I pick. Celine, would you like to get rid of the n's or the d's? Your choice. The n, I like it. So Celine's choosing to get rid of the n's. Okay? The n's are gone. Shh. Now I have to multiply by negative. So I'm going to multiply that whole top equation by negative what? Negative 5. Good. So that goes here and here and here. So I'm going to combine whatever that is. What is negative 5 times n? Help me out. Negative 5n. Plus, what is negative 5 times d? Negative 5d. Because I'm doing it here and here. Okay, help me out. Negative times positive is going to be negative. What is 5 times 29? I don't know. Help me. 145? Did you calculate that?
Yeah.
Oh, sweet. I just want to make sure. Okay, so, Celine, you see these two equations right here? If I add those together right now, what falls or what goes away? N is gone. Stephen, remember we started this with you, pal. So the n's are gone. 10d added to negative 5d is? 5 what? 5d? 215 plus negative 145. What's 215 minus 145? You have the calculator. 215 minus 145. 70, okay? So I have 5 times d equals 70. Divided by 5. What's 70 divided by 5, please? 14. Okay. Shh. Guys and girls, of those 29 coins, I know that 14 of them are dimes. How many of them have to be nickels then? 15 of them. How do we know that? Well, I know that my n plus d is equal to 29 coins. I know that my d is 14. So if I solve this, I find that I have 15 nickels. Say, Stephen, you know that you have 15 nickels and 14 dimes in that piggy bank of yours? Giddy up. Hey,
Man, you got $2.
he is loaded. All right. So, hey, guys and girls, there is one thing that I covered on this problem that I want to talk about a little bit. I want to talk about this because this is frustrating to me. Okay, does a decimal make a difference?
Yeah.
Do you think in the real world a decimal makes a difference?
Yeah.
Yes.
Like if I went and said, hey, how much money do you have in your checking account? And you say, oh, I have $135.15. Is that different than saying I have? So if I go to my checking account and said I had this in my checking account, if I drop the decimal, is that a different number?
Yeah.
Yeah. I mean, I wouldn't mind having this much money in my checking account. That means $13,515. So the decimal means something. Now, I'm going to tell you all how to get rich right now. I'll tell you how. Okay? Now, y'all heard that story about some old lady that got her coffee from McDonald's and didn't realize, they didn't tell her it was hot, she spilled it on her lap, and she made millions. You guys remember this little adventure? And it might have been before you guys were born, but it was one of those lawsuits where you're like going, dude, are you kidding? Like, and she played this whole thing going, but I didn't know it was hot. It's like you ordered coffee, you put it in your lap, and it spilled.
What do you expect?
I understand, but she's now a multimillionaire. And now if you go to McDonald's, the coffee cup on there says caution, hot, and then they might have it in some other languages too, just in case. Okay? It's to all of us like some sort of like, well, duh. Yes, ma'am. It happens. There's some frivolous lawsuits out there. Do you know that? Here's another one. Do you know poor McDonald's? I mean, they only make like $1 jillion, and they have Ronald McDonald houses for the parents for the sick kids to go to. But do you know that McDonald's was also sued because they have a hamburger? They have the Big Mac, and that's no big deal. I mean, it's a good hamburger. I enjoy it. But there's another hamburger called the Quarter Pounder. Do you know that somebody sued McDonald's because they ordered a Quarter Pounder? They took everything off of it. They weighed the patty and no longer weighed a quarter pound. And so they sued McDonald's for this. Now, if you go to McDonald's, you order the Quarter Pounder, there's a little asterisk that says this is the net weight before cooking. Because when you cook meat, the fat burns off a little bit and it doesn't weigh as much. So think about this. Now, these are all, I just wanted to point out some silly lawsuits that people have won big money. Okay? You still with me? Uh-huh.
The fact doesn't really change that. I mean, it wouldn't be officially a quarter of a pound if you see something in like decimals, like a number or two under it, but must it puts a lot more things way more than fat.
I know, but when you have like a 15 or 20% fat, you know, in your patty, 15 or 20% of your product is now burning off, and so that the mass of it would weigh less. And to me, I'm pretty sure if I've eaten a quarter pounder, and I know I've eaten a few in my life, I've never been like going, you know what, I want to see. I kind of looked at it as, hey, I want a quarter pounder with cheese. It was the larger patty than the Big Mac. The Big Mac has the smaller patties to them. So that's just kind of, yeah, Gage.
And then there are guys that see Red Bull for not
Do what? That sued what?
Yeah, there was a guy who sued Red Bull for because it didn't give him wings.
What?
I
I can see that. Now, guys and girls, I'm going to tell you this. There's a small little restaurant that y'all might have heard of. Now, they've been in the news because they got a whole bunch of people sick because, yeah, Chipotle. So, Chipotle, do you agree that Chipotle is in multiple locations?
Yeah.
Okay, do you think Chipotle might be in other states as well?
Yeah.
Probably. Now, I personally don't love Chipotle. Like, that's not my go-to place. Okay? I personally think that Chipotle burritos kind of taste like cardboard. Okay? I'm that guy. I grew up in Arizona. You put hot sauce. No, I am not racist. You put hot sauce on a burrito. It's supposed to be warm in your mouth. Not like temperature warm, but like, ooh, this is spicy. Okay? There isn't a hot sauce at Chipotle that I couldn't drip into my eyes and I'd be like, okay, it doesn't hurt. Okay, they're like, oh, you want the hot sauce? And they put it on going, there's no hot sauce. I like spice. I like
Barbecue.
That's why you
no,
gotta
not
put your own
barbecue.
hot sauce.
I like that stuff that you're like, woo, 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 and you're turning red, you're sweating. Over there at Rico's.
No, I had the bougie.
I have heard that is just, I haven't gotten it. So I bring it in, man. I'll try it. I love it. Woo.
Don't do
Good
it.
stuff. Hang on. So next time you go over to that Chipotle and get that baritone, that cardboard tasting apparatus that they have, okay? Take a look at their soda menu, and their small soda cost
Whoa.
Their small soda costs you that much.
Whoa.
Okay? Now, how much do you think that is supposed to cost? 79 cents. That's what it looks like, yes? No, 79 cents, if you use the cent sign, is written like this. 79 cents with the dollar sign is written like this.
Oh my gosh.
You know what this means? We're talking about 0.79 of a penny.
Yay.
So, y'all walk in, got that penny in hand, saying, I'll take a small soda. Okay, it'll be 79 cents. Give them the penny, say, give me some change. Like, no, that's not what it is. They're like, no, that is what it is. And they're like, what's the big deal of a decimal?
Wait, do they actually say that on the paper?
Yeah, it is written like that.
It's written 0.79 cents.
0.79 cents.
Keep the change.
So,
The change, yes.
so seriously, think about this. If you could have some old lady who spills hot coffee on her lap claiming negligence on, I didn't know it was hot and they didn't tell me, or if someone could nail McDonald's for selling a quarter pounder that didn't weigh a quarter pound after it was cooked, don't you think that 0.79 cents, that decimal, they're ripping off the American public?
Yes. We need to sue.
So, there you go. Now, guys and girls, I only require a 5% finder fee on this. So whatever you make in this lawsuit, I only require 5% or a brand new Corvette, your choice. All right. Got it?
Well, yeah, if some chick could make millions of
So,
dollars.
guys and girls, for next time, other than a frivolous lawsuit against Chipotle,
0.79 cents. Put that out.
I would like you to work on. Let's have you work on worksheet 3B. But for right now, I just want you to do 1 through 9 on 3B. Okay? It extends to 10, 11, 12, 13, and 14. But I just want you to do worksheet 3B for next time.